Hello everyone, and thanks for watching Edupedia World videos. I'm Manish Agrawal, and in this session of mole concept we'll start with our next concentration unit, that is of molarity. Right, we'll see what molarity is, we'll make some calculations and see some examples. So first, what is molarity? It is the number of moles of solute present in 1 liter of solution. Right, you have to remember that molarity, again, it is nothing but a concentration unit used to quantify solutions. Okay, so we will be representing amount of one substance with respect to another. So in molarity we represent moles of solute with respect to volume of solution. Okay, so it is going to be ratio of moles of solute with volume of solution. Next point, it is volume in liters. Alright, so this is important, that volume here is to be present in liters. So let's see mathematically what molarity is. Molarity is, it is equal to number of moles of solute. Okay, so first you identify which is the solute particles, then you calculate their moles and you write it here, and divide that moles with volume of solution. Okay, so you multiply here moles of solute, alright, in the numerator, and in the denominator what you have is volume of solution, that is in liter. Okay, it cannot be in milliliter or meter cube or centimeter cube, it has to be in liter. So molarity, its unit is also called molar. Okay, and represented by capital M. It has its own unit, molar. It is represented by capital M, and obviously 1 molar is equal to 1 mole per liter. Okay, so one unit of molarity is moles per liter. Other unit and more common and standard unit is molar. Okay, represented by capital M. So 1 molar, okay, 1 molar is equal to 1 mole per liter. Okay, so 2 molar will be equal to 2 moles per liter, and so on. Okay, now you can also use millimole or milliliter. Okay, that is, if you simply multiply 10 to the power minus 3 in the numerator and 10 to the power minus 3 in the denominator, then what you get is 1 mole per liter is also equal to 1 millimole per milliliter. Right, obviously I can multiply same quantity both in numerator and denominator, it won't change the value. So I can use milliliter instead of liter, but then I will have to use millimoles instead of mole. Okay, so this is what we have to study about molarity for now. So let's see in further detail. Some points that you have to note here. First, volume used in the denominator is volume of solution, and volume of solution, as we know now, is always equals to volume of solute plus volume of solvent. Okay, that is all the quantities present in a solution, add their volumes, and what you get will be volume of solution. Okay, so let's say this is solvent, let's say this is your solvent. Okay, and this represents all the solutes. Okay, there can be more than one solute, so all the solutes, so you add their volumes and you get volume of solution. Second thing that we know here is that if one of the quantity is solid, okay, one of the quantity is solid, let's forget it here and note it over here. If there is solid and there is liquid, okay, then we also know that I can neglect the volume of solid. Similarly, if there is liquid and there is gas, then I can neglect the volume of liquid. And similarly, again, if there is solid and there is gas, then again I can neglect the volume of solid, usually, unless you have exact information about volumes of each quantities, and you can see from the numbers that one is cannot be neglected with respect to another. Okay, then we can make these assumptions, otherwise you have to do accurate calculations. Next point that you have to note here is that Molarity is what? Moles by volume. Let's say N is moles of solute, V is volume of solution. So M molarity is equal to N by V. So here I can simply take volume to the left side. If I take volume to the left side, what do I get? Molarity multiplied with volume of solution is equal to moles of solute. So this is another relation that we can derive from here. Okay, that is moles of solute is equal to molarity multiplied with volume of solution. So this is going to be a very important relation for calculation of moles. So if I have a solution, say of salt in water, then I can simply calculate molarity and multiply it with total volume of my solution to get how many moles of salt I have added to the water. Let's say if I added both salt, that is NaCl or any other salt, calcium chloride, potassium chloride, there are numerous kinds of salt, plus sugar. Okay, again you can have different kinds of sugar, say glucose, fructose. So I have added salt and sugar in water. Now I have calculated molarity. For calculation of molarity, I needed moles of solute by volume of solution. So I have to take moles of solute. So which solute? Okay, which solute are we talking about here? Salt or sugar? Water will be my solvent. Alright, water will be my solvent. So if you take moles of salt, then you get molarity of salt in water, okay, or in that solution. If you take moles of sugar here instead of N, then you will get molarity of sugar in your solution. Okay, or if you add their moles, if you add both the moles and then calculate moles by volume of solution, then you will get molarity of total solutes in your solution. So usually you will have to deal only with one solute at a time. Okay, so in that case, this formula will directly give you moles of that particular solute, the one you are dealing with. Okay, so remember this formula as well. Moles of solute is equal to molarity multiplied with volume of solution. Okay, you have to remember that this is volume of solution, not solute, not solvent. It is total volume. Okay. Let's see some of the properties of molarity. First property, it's very simple. It is inversely proportional to volume. First, you might already know the meaning of inversely proportional. Inversely proportional means, say I have two quantities A and B. Okay, I have two quantities A and B. When I say A is inversely proportional to B, it means A is said to be directly proportional to 1 by B. This sign over here is the symbol for directly proportional. So when I say A is directly proportional to 1 by B, that is other way of saying A is inversely proportional to B, which means if I increase B, A decreases, or if I decrease B, then A increases. Okay, that is, they are inversely related. If I increase one quantity, the other falls. If I decrease one quantity, the other increases. So A is inversely proportional to B. So this is how you write it. So when I say molarity is inversely proportional to volume, what I mean is that molarity will be, so molarity, that is capital M, is inversely proportional to volume. Okay. It's quite obvious because molarity is moles by volume. So if I increase volume, obviously molarity will decrease, or if I decrease volume, molarity will increase. Okay, because it is inversely proportional to volume of solution. Okay, obviously volume of solution is volume of solute plus volume of solvent. Okay, so whether I increase volume of solute or whether I increase volume of solvent, the volume of solution will increase, and that will result in decrease of molarity. Okay, that is, unless you are completely neglecting the volume of solute, in which case it will get affected only with volume of solvent. Alright, let's see next property. It is inversely proportional to temperature. See, temperature, relation of temperature with molarity cannot be generalized. Okay, we can only see most cases and From that we can make some assumptions. So usually when I increase temperature, usually say temperature is T. If I increase temperature, molecules expand. Say I have water, or say I have some liquid, okay, any liquid. Now say these are how the molecules are arranged in a liquid. Now if I increase temperature, they get further apart, okay, their kinetic energy increases, they move with greater velocities and they move further apart from one another. That is, upon increasing temperature, volume increases, and this increase in volume, we have seen volume is inversely proportional to molarity. So this increase in volume will result in decrease of molarity. Okay, so increase in temperature results in increase in volume, which results in decrease in molarity. So this relation, increase in temperature resulting in increase of volume, is not always true. It actually depends on the temperature range, it depends on the liquid in question, okay, or the gas. For the gases we can say that it is always true, but for liquid it might vary depending on the liquid in case. So hence this relation between temperature and molarity might also not be always true, but unless otherwise mentioned, we will assume that it is always the case that molarity is inversely proportional to temperature, because most of the time, even 98-99% time, it is true. Okay, and lastly and obviously that molarity is going to be directly proportional to the amount of solute, assuming constant volume. Okay, that is capital M, molarity is going to be directly proportional to moles of solute or mass of solute. Okay, assuming constant volume. Why? Because molarity is what? N by V. Molarity is equal to N by V. So if I take volume to be constant, then obviously on increasing moles, molarity will increase. So I can increase moles as by saying that I have added some more moles of solute, or I can say I added some more mass of solute. Increasing mass means increasing moles, alright, which results in increase of molarity. But assuming that volume remains constant. Say you have two liquids, alcohol and water. So in that case, if I add more alcohol, okay, both are liquid, so on adding more alcohol I am actually also increasing volume. Okay, so I am increasing the moles of solute, but I am also increasing volume of solution. Why? Because I have added a liquid. So in that case I cannot directly say that increase in moles has resulted in increase of molarity. In that case I will have to make the exact calculations and determine. So only when we assume that volume is constant, we can say that molarity is directly proportional to moles. Let's see some examples for calculation of molarity. Okay, and then this topic will be much more clear to us. Say you have 87.75 gram of sodium chloride. We know what sodium chloride is. That is table salt. Sodium chloride is also called table salt. That is the one which you use for your daily diet. Okay, it has other substances in it, including major substance is sodium chloride. So table salt, 87.75 gram of NaCl is dissolved in 500 ml of water. Calculate the resultant molarity of solution. So I have to calculate molarity of solution. I know that molarity is nothing but moles divided by volume of solution in liter. Okay, volume of solution in liter. So first I have to calculate moles. Okay, first I have to calculate moles. How do I calculate moles? Moles of solute. So solute is obviously NaCl, and I know that moles is nothing but mass, given mass divided by gram molar mass. Okay, we already know this relation now. So moles here will be mass of solute, that is NaCl here is 87.75 gram, divided by gram molar mass. What is the gram molar mass of NaCl? Gram molar mass of NaCl, it is a molecule with molecular formula NaCl. So it is going to be mass of Na plus mass of Cl. Sodium has atomic mass of 23. Okay, you don't have to remember that, it will be given in your question. So sodium has atomic mass of 23. Chlorine has atomic mass of 35.5. So if we add the two, what I get is gram molar mass of NaCl, which is 58.5 gram. Okay, which is 58.5 gram. So once I do that, I can simply calculate moles. I can calculate moles as 87.75 divided by 58.5, which will be, if you will calculate this, you will find that it is equal to 1.5. That is, there are 1.5 moles of NaCl in this solution. So I have done the first part. Okay, second part will be calculation of V, that is volume of solution. Volume of solution is volume of solute, that is NaCl plus volume of water. Okay, now NaCl is a solid, salt is a solid, and water is a liquid. So I can simply neglect the volume of NaCl. Okay, and I can take volume of water to be volume of solution. But volume of water given to me is 500 ml. Okay, 500 ml. Now this is volume in milliliter. I have to convert it into liter. So instead of ml, what I need here is liter. Okay, so I simply multiply it with 1 liter. Now 1 liter is how many ml? Okay, I multiply it 1 liter and divide with 1 liter. 1 liter is actually 1000 ml. Yeah, 1 liter is actually 1000 ml. So to convert 500 ml into liter, I can multiply it with 1 liter divided by 1000 ml. That is, I have multiplied it 1 liter and divided by 1 liter. So basically I have done nothing. I have simply converted it into 500 ml get cancelled. I get half liter. I have simply converted ml into L. Okay, so now I have both the parts which I need to calculate molarity. I have moles of solute, which is 1.5, and I have volume in liter, which is half, that is 0.5. What do I get? I get 3. So molarity of this solution is 3 mole per liter. That is, it is a 3 molar solution. Okay, that is how you say it is a 3 molar solution of NaCl in water, or it is a 3 molar aqueous solution of NaCl. When I use the term aqueous, it automatically means that solvent is water. Okay, so it is a 3 molar aqueous solution of NaCl. Okay, so you can also learn how to read this. Okay, let's see. I have 3 molar aqueous solution. So one way of reading it is, we are done with the example. We have come up with our answer. We have calculated the molarity or resultant molarity. Okay, resultant molarity means that the molarity which is finally present of the solution. So when, say, instead of this question, if you have been given that I have 3 molar solution of NaCl and I have been asked to interpret this data. Okay, I have 3 molar aqueous solution of NaCl. So how do I interpret it? See, you have to remember this, what I am doing here. This implies, what is molarity? Molarity is moles of solute present in 1 liter of solution. So 3 molar aqueous solution of NaCl implies I have 3 moles of NaCl. I have 3 moles of NaCl in 1 liter of water. Okay, so this is how you interpret this data. If instead of this question, if you were to start with, say, 3 molar, so this is how I interpret it. It means if I had 2 liter of water instead of 1 liter, if I had a 2 liter bottle, so I would have had 2 into 3, 6 moles of NaCl. Okay, so this is how you interpret this information. 3 molar means 3 moles of NaCl in 1 liter of water. Okay, let's see another example. Let's continue this question actually. So in this question, from this previous question solution, I take 100 ml. So I have 87.75 gram NaCl. I have 87.75 gram NaCl in 500 ml water. So ultimately I have a 500 ml solution. Okay, so my container has 500 ml solution. Okay, and out of this 500 ml solution I have taken 200 ml solution. That is, I took 200 ml and separated it out in a new container. Here I have 200 ml solution, 200 ml of NaCl plus water, and I have been asked to calculate the mass of NaCl present in this new container. Okay. First let's see what all information is present with me. Okay, I know, sorry, instead of 200 it is 100 actually. Okay, the question says 100 ml. Okay, I have separated out 100 ml of solution. Okay, this is 100. So what all information is present with me? 100 ml of solution. Okay, there is another information present with me, that is molarity of this solution. Okay, I also know molarity of this solution. I know the volume of solution 100 ml, but I also know molarity of this solution. How do I know that? From the previous question. In the previous question I calculated that molarity of this solution is 3 molar, and we know that we are only talking about homogeneous solution. That is, every part, every nook and corner of this container will have 3 molar solution. So if I separate out of this 500, even if I separate out 100 ml in a new container, the molarity won't change. Okay, that is why homogeneous solutions are so important. Okay, once we calculate their molarity, we can transfer them as many times as we like. So where they are manufactured, then they are transported, okay, then they are stored, and then they are sold to our laboratories in schools and colleges. So molarity where they were manufactured, from there up to your laboratory, it always remains constant as long as you haven't messed it up, okay, by addition of impurities or mishandling. So molarity of this solution is 3 molar. So I know molarity, I know volume. So what can I calculate? I can calculate moles. Moles of solute, if you remember, moles of solute is molarity of our solution multiplied with volume of solution. Molarity is 3. Okay, volume is 100 ml. Now this is in milliliter, but I have to use liter. Okay, always use liter when molarity is concerned. So how do I convert ml into liter? I simply divide it by 1000. Okay, from the previous example we know how to convert ml to L. We simply divide it by 1000. So what do I get? 3 by 10 moles. That is 0.3 mole of NaCl. That is solute present here in this 100 ml is 0.3 mole. This is absolute quantity of solute. It is not relative quantity in this container. Okay, in this 100 ml I have 0.3 mole of NaCl. So if I have moles of NaCl, I can very easily calculate mass of NaCl. How do I do that? N is equal to W by Gmm, right? Mass upon gram molar mass. This is another formula for moles. So this implies mass is equal to moles multiplied with gram molar mass, and my moles are 0.3, that is 3 by 10, and gram molar mass we calculated in previous question. Gram molar mass of NaCl is 58.5. So I can simply make these calculations and report my answer. These many grams of NaCl are present with me in the solution. Okay, so this will be my final answer. Okay, after you calculate the exact value which comes out from here, this will be my final answer. Okay. In the next session we'll continue with molarity. Okay, we'll basically focus upon dilution and mixing of solutions. Okay, and how do they result in changes in the molarity, okay, and its quantity and as well as quality. So until then, and once again, thanks for watching Edupedia World videos.